Alright, lesson 3, ignition systems. Describe tasks. Describe the application of the fundamentals of electricity with the components, wheel, vehicle, battery, ignition system. Conditions. Give information, construction, operation, ignition, coils, distributors, secondary wires, spark plugs, advanced mechanisms. Learning of reference TM9 8000. Learning event 1. Describe the principle of the battery ignition system. Introduction. Ignition system. Simple act of walking in the dark room, flipping on the light switch, and illuminating the previously dark room. Something would take for granted in everyday lives. We never consider the vast electrical network involved with making up the light to come on. Let's discuss a few examples of a simple act. First of all, the housing must provide electrical source of power originates of the hydroelectric plant consists of a huge dam generating a length of water pressure huge for the generator to convert the water pressure to electrical power. This power is then carried with a high voltage wire of the step-down transformer near your home. This is reduced the transfer of the, through the wire of the fuse box into the home. From the fuse box with electrical power is carried by wires to switch you flip down eventually with the light fixture for the provide with illumination for your room. When you step in with the car, start with the again perform what appears to be a simple act. You merely turn the ignition switch for the start of this engine with the running of the then relieve the switch. Now let's see what you actually involved. How previously studied the spark produced the ignition instant with the fuel air mixture for the cylinder compressed the proper pressure will cause the combustion that will drive the piston down. We also knew that the piston return with the same piston again with another spark will ignite the mixture again. We just now think of the sparks being occur with just the right instant of the 8-cylinder engine running at 4,000 RPMs. Ignition system 1 must interest the trouble system found with the gasoline engine with the interested because it must build up vehicle battery voltage of 24 volts but less than 25,000, 30,000 volts must do the many times per cycle if the troubleshooting must be something that can do wrong in the system. To give it an idea, somehow if the ignition system builds up the battery voltage as too much of 30,000 volts at the spark plug, at least takes 6-cylinder engine turning 4,000 RPMs.
Hey, see you guys here. Put shoes on, go out watching.
Testing. Okay. Alright, starting as interrupted. We also know that when a piston returns to the same position, again, another spark will ignite the mixture. You just think that these sparks might occur with the just right instant with the 8-cylinder engine running at 4,000 RPMs. Ignition system, one of the most interesting troublesome system found. The gasoline engine it's interesting because it builds up the vehicle's battery voltage from about 24 volts or less to as much as 25,000, 30,000 volts. It must do this many times per second. It is troublesome because of some of the things you can do and do wrong in this system. To give you some idea about how fast the ignition system builds up battery voltage as much as 30,000 volts at a spark plug, let's take 6 cylinders engine turning at 4,000 RPM. See what ignition system does. As you know, a 4-stroke cycle engine, 1/2 of the cylinders fire during each revolution of the crankshaft. This means 3 cylinders and 6-cylinder will fire during each revolution. But multiplying the number of RPMs by the number of cylinders firing each revolution, we found the ignition system, for example, is 3 times 4,000 at 12,000 high voltage surges and sparks per minute. This is equal to 200 parts per second, 200 sparks per second. The ignition system not only builds up the high voltage surge of fire exhaust mixture with the engine cylinder, it also times and paces surges that will occur with each of the cylinder just as it piston reaches the end of the compression stroke. So we can say the ignition system has just built up the high voltage surge and timing it to occur each cylinder precisely with the right instant. How this is done in the story of the ignition system. The intent of the lesson is to provide you with the knowledge and construction operation of the components of the ignition system that provide the spark need not to make an engine run. Battery ignition system components. Although other findings that are usually added to the basic ignition system consist of the following items. The vehicle batteries of the generator to supply with the required current. While the engine is being cranked, the battery is supplied with a low voltage current for the ignition system. While the engine is running, the generator is charging, and it takes over the job of supplying the current to the system. The ignition switch open and close the circuits between the batteries and other components of the ignition system. We usually stop the engine by turning off the opening and the ignition switch. The ignition coil, the device that converts the low voltage from the batteries to the high voltage needed to ignition fuel air mixture in the engine cylinders. The engine distribution alternately opens and closes the low voltage circuits through the coil. It also receives the high voltage circuit of the coil to distribute to the proper cylinders to burn the fuel air mixture. The low voltage circuit is better known as the primary circuit, while the high voltage circuit is better known as the secondary circuit. In the remainder of the lesson, we will refer to them as primary and secondary circuits. High tension voltage wires carry high voltage surges to the spark plugs. Spark plugs provide air in gap 8-cylinder with a high voltage surge for the air across, which for the reason we need is such high voltage in the second circuit, it takes a lot of voltage to force the current to jump across the gap between the electrodes of the spark plug. The current arcing across the air gap does actually ignite the fuel-air mixture. The primary consists of the components between the battery and the breaker points, including the breaker points. The secondary circuit consists of the secondary winding of the coil with the distributor cap of the rotor, the distributor spark plug pliers, and the spark plug. Learning event 2. Describe the construction and operation of the ignition system. Ignition coil. The ignition coil is really a step up for transformer. Probably noticed to the transformer light wire poles near your home. Usually step down transformers will change high voltage and transmission wires on the poles to 110 volt current we use in your home. Our ignition coil does just the reverse of a step-down transformer. It changes the low voltage supplied by the battery generated to the high voltage needed at the spark plugs. To understand how the coil works, review the relationship between electricity and magnetism. You know that the current flow through a conductor magnetic field is created around the conductor. The strength of the magnetic field depends on the number of loops of the coils of the wire amount of the current flowing through them. The magnetic field differs with the flux path, whereas in single to double the multiple coil wire carrying current. We make a magnetic field stronger and simple to increase the number of the coils in terms of wire. Strength of the magnetic field around the coil has been increased in two other ways. First, it can be strengthened by the increased amount of the current flowing in the coil, and second, it can be strengthened by inserting a soft iron core inside the coil with a wire. Placing a soft iron core on the center of the coil will provide an easier path of magnetic lines of force are put into another way. The core will increase the number of lines of force because it reduces the resistance in the magnetic field. It's much easier for the lines of force to travel through an iron core through the air than through air. Now recall the magnetic field can induce the current of the conductor provided the conductor move the field involved with the move across the conductor. In case of the OR coil, however long as the direct current flows through the conductor, no current will induce because there is no relative movement between the coil and the magnetic field. Alright, 12 shows the ignition coil construction. Starting with the sealing nipple, then the high tension terminal, coil cap, primary terminal, spring washers, sealing gaskets, coil case, lamination, porcelain insulator, primary winding, secondary winding. Alright, now let's stay with the construction of the coil. The illustration shows the coil that has been cut away with the show of the primary winding, secondary winding, soft iron core, and the terminals with the winding of the primary winding, the large wiring, and the secondary winding is small wiring. The actual diameter of wire used for the secondary wiring of the coil is about the same as the one with the hairs of the head, less than 5,000th of an inch, which a small wire, which can have thousands of turns of wire, secondary wiring in small space. On the end of the secondary winding is connected with a high tension, leading the secondary terminal with the top of the coil with the other end of the usually connected with the one end of the primary winding. Always it may be grounded to the metal such as surround the coils in the core. There are two terminals with the coil assembly with the primary winding. One of the terminals is connected with the wire with the ignition switch, which is connected with the disconnect with the coil from the battery. The other terminal is connected with a movable breaker point in the distributor. When the ignition switch breaker point is closed, the current flows with the primary winding of the coil, with the current flowing in the few hundreds of the turns of the primary winding builds up the strong magnetic core of the field. Looks around with the primary secondary windings made with the iron core with strong electromagnet. Remember the induced voltage of the conductor. We must magnetic field the relative of the motion between the conductor and magnetic field. We do get a relative of the motion between the field and the conductor for the contact current starts with the primary winding with the builds up too slow with the inducing the voltage secondary winding strong enough to jump the air gaps and with the distributed cap of the spark plug with the magnetic field reach of the magnetic strength. There is a relative motion between the windings, so no current will be induced in the windings. Suppose we didn't shut off the current flowing through the primary winding, opening up the breaker of the magnetic field will collapse and disappear. As it collapses, lines of force would cross the primary and secondary winding at tremendous speed. Line forces collapsing with the winding would induce the voltage in each term of the coil. Winding voltage induced with the primary winding is called self-induced voltage because the magnetic field was created by the primary winding in the first place. The voltage induced in the secondary winding is a result of called a mutual induction. Secondary winding did nothing to create the magnetic field, but a voltage induced into it because it is mutually located with the primary winding. Alright, so how much voltage is induced with the primary and secondary winding with the collapse of the magnetic field? But it would depend on the speed of the field collapse, the speed of the motion, with the number of turns of wire each of the coil. There are more turns of the wire with the winding, the greater than inducing the voltage of the primary winding with the move of the most automotive coils. There are a few hundred turns of wire, and voltage induced will be about 200 to 250 volts. Because the primary circuit is now open, this is why the magnetic field is collapsed. The voltage is now going anywhere except into the capacitor, which they study later. While magnetic field is collapsing across the few hundred turns of the primary winding, it also moves across the thousands of the turns of the secondary winding. Voltage induced in each term of each of the winding is the same. Since secondary winding has many more terms, the total voltage induced will be those thousands of volts. The voltage is high enough to force the current flow out of the coil through the secondary terminal through the conductor to the spark plug in the cylinder. Thus, the current is forced in the high voltage jump air gap of the ignition fuel fixture. This current returns to the source in case of secondary winding of the coil. Alright, your ignition distributor. We stated earlier, lesson of the ignition distributor, two separate distinctive jobs. One job involved the primary circuit, the other job to determine the secondary circuit. Let's discover the primary circuit first. For these parts, let's discover the distributor, breaker points, distributor cam, and a capacitor or condenser. Typical automotive ignition systems show the battery ammeter of the ignition switch, the primary circuit, low tension, distributor cap, distributor breaker points, spark plug, combustion chamber, spark plug, high tension, distributor cap, and rotor. The points of the two contact with the one stationary grounded with the other insulated with the movable mount of the distributor, the spring end with the movable breaker arm, and similarly with the angle of the primary lever of the coil. Breaker arm is mounted with the pivot post is insulated with the post by a fiber brushing. The entire arm can swing back and forth on the pivot. The post with the fiber rubber block. A fiber rubber block is kept with the contact with the distributor cab of the distributor shaft. During the time of the breaker points are open, the distributor shaft is driven in time with and at 1/2 the speed of the engine crankshaft. On most distributors that it will have one cam lobe for each cylinder of the engine. The grounded point will be is attached to support with the term of the mount of the plate inside of the distributor. While this point is often called the stationary point, it can be moved to adjust the point opening. This is done by moving the adjustable able point either near to the farther from the insulated point. On some distributors, the adjustable point is moved with the support with making adjustments, and with some other applications, the support is moved. Let's see what happens when these parts of the distributor is operation. Or when low side of the cam is towards the rubber blocking the breaker arm springs hold with the contact points close at the time of the current flow of the batteries to the ground. Then for the ground contact, the insulated coil contact from there. From here, it will flow from the primary windings to the ignition coil. This cover the magnetic field to build up and around the coil. From the primary coil to the coil, return to the closed ignition within switch to the battery. Current will continue to flow as long as the circuit is used. The cam turns enough. The lobe on the cam will contact with the rubber blocking, pushing the contact pins points open. They open into the primary circuit with the magnetic field, but will collapse around the windings of the coil. As the cam continues to turn, the lobe will move under the rubber block, and at this time the spring will again close that point. So each time the lobe in turn strikes the rubber block above, the action takes place. So far we've seen the magnetic field builds up the ignition coil while the points are collapsed, and while the cam lobe open points, the circuit is broken, the cowl magnetic field collapses. This induces very high voltage in secondary winding of the coil. The high voltage forces the current to jump the air gap of the spark plug electrodes to connect the fuel air mixture in the cylinder. In practice, however, the creating the high voltage in the coil is not quite so simple. Actually, electricity, like anything else, tries to remain in motion. It resists every effort to change the stop of its flow. Also, magnetic field of the coil collapsing around the primary windings as well as the secondary. This builds up voltage primary windings, and the result of the current will arc across the points. Arcing will cause points to burn and be destroyed at a very short time. It also causes magnetic field to collapse and collapse more slowly. Remember, we get the high voltage induced coil secondary windings. Only magnetic field collapses really fast. Reduced arcing at the points of speed, the collapse of the magnetic field of the capacitor is used for every year. Every automotive mechanics have referred to the capacitor as a condenser. As you will see, however, the capacitor is a more accurate term. The capacitor consists of the two sheets of the metal foil called plates, which are separated in insulating paper, then rolled together. One of the rolling foil is connected with a wire lead, while the other roll is connected with the metal cam and case. Lead of the capacitor is connected to the same terminal with the insulated breaker point, but the capacitor is grounded with the distributor plate by the screw. The parallel connection between the current goes through the points of it into the capacitor, while the points are closed. The current goes through the points because the foil of the strips of the capacitor are insulated from each other. As the coil lobe moves from the rubbing block, barely separates the points of voltage. Primary windings will start to rise. The tenth of force of the current across the points of the capacitor now offers an easier path for the current to take. So the current will flow for the capacitor, charges electrically. By the time it charges the capacitor, the points will be open wide, and also that the current can no longer jump the gap between the contacts in manner the capacitor breaks the point, protects the break points. The secondary circuit of the distributor consists of the rotor distributor cap that is discussed in the following paragraphs. The distributor cap is made by the bakelite with some of their haired insulating material. It contains terminals usually called towers for each spark plug wire with a high tension wire for the secondary terminal with the ignition coil with the contact of the terminal extends through the cap. The rotor is switched to the backlight is mounted with the rotated with the driver's distributor shaft has a flat spring type conductor that stays in contact with the coil secondary terminal in the center of the distributor cap. The spring in turn connected to blade type contact with the top of the rotor. The rotor is rotated with the distributor shaft. The contact passes very close to each spark plug terminal in turn. Engines used in the Army tactical wheel vehicles designed with they operate underwater. This means that the ignition system must be waterproof. The distributor window is made with waterproof with the cover of the mount over the distributor cap. The ignition coil is mounted inside of the distributing housing, but is also protected with water by cover. The covered contains threaded waterproof terminals for spark plug cables. Your secondary winding spark plug. Secondary winding is part of the high voltage circuit of the outside of the distributor. The civilian type of the vehicle is that wire consists of the cable, the wire from the ignition coil to the center tower in the distributor cap. Other wires lead for the outside tower with the spark plug. The wire themselves are very small, but the view strands of very fine wire with the insulation very with the vehicle to prevent high voltage of a current that traveling through from the wire arcing with the ground before it gets to the spark plug. Other types of cables may be used with a carbon-saturated string instead of wire as a conductor. The main reason for this is to cut down noise that can be picked up by the radio. Waterproof ignition systems, high-tension cable inside of the waterproof tube, woven metal shielding around the tube will reduce radio interference when the engine is running. The nut waterproof seal used on each end of the cable to make a waterproof connection at the distributor and the spark plug. Figure 24 shows typical spark plug construction. Hot heat range, hot, cold, medium. Terminal seal, insulated flats and wrenches. Electrode seal, thread, side electrode, gap, gasket seal, fit ribs for reducing flashover. The spark plug. The remaining of the secondary circuit with the tip of the metal shell with the personal porcelain insulator with electrode extending through it with the ground with the electrode with attached with the metal shell. Shell external threads are allowed with a screw with the thread hole leading with the combustion chamber with the insulator with the grounded electrode separated with the air gap, also called the spark gap, at 25 thousandths to 40 thousandths of an inch, and operating a high voltage current produced with the secondary winding with a coil and will arc across the spark gap to ignite the fuel. Spark gap plugs are used with the waterproof system, much like one of those discussed, except the type plug is completely surrounded by metal shell, which for the nut of the spark plug is threaded, but the shell is both shielding and waterproofing the spark plug. Spark plugs are usually classified in two ways. First, the diameter of the thread hole into which they are screwed and is in 10 millimeter, 14 millimeter, 18 millimeter, and so forth, and second, according to the heat of the range of the plug. The heat range of the operating temperature for the spark plug will determine the length of the insulator nose. The spark plug with the operation control the heating and the burning of the fuel. For the plug with the cool of the heat will pass through the insulator nose. The shell plug from which the cylinder head of the engine block with the farther the heat with the go to get the shell of the plug. The higher spark plug will operate. This means the spark plug will shorten the insulator nose will operate with cooler with one long insulator nose. The correct spark plug for any given engine very considerable. A hot plug will work better in an engine that is burning oil, one that is operated with a low speed and short distance. A colder plug may be needed for some engines with a high speed over long distances under heavy loads. Examine insulator nose. Determine the spark plug with the correct heat range is being used. If the deposit of the nose of the light gray or brownish ash heat range is correct. If the nose is covered with black gummy carbon, the plug is too cold. A blistered nose or one of the porcelain chipped off is probably too hot. Before any further, let's see what happens where all things discussed farther in this lesson operation. Let's start the number one piston going up the compression stroke. At a time, the air fixture of the cylinder is being squeezed on the smaller air with the combustion chamber. The ignition switch breakpoints closed. Magnetic field is built up with the ignition coil. The piston reaches the top dead center of the compression stroke with the exact point where the depend on the engine design, engine speed. Ignition of the fuel should take place. This may be possible with the distributor is turning the time with the engine. At the cam, the distributor trim with the one cam lobe with the contact with the running of the block with the insulator with the distributor with the proper time with the engine. Contacts will open with the time of the fuel will show up with the contact with the distributor. Open the primary circuit with the broken with the magnetic field collapse with the collapse of the field induced the high voltage and then secondary winding cool of the coil. High voltage currents then pass through the same with the distributor cap to the rotor. The rotor will then type at this type in line with the number one tower over the distributor cap. Current pass with the top over the spark plug wire onto the spark plug. As to the engine distributor continue to determine the remaining spark plug receive the high voltage from the coil with the proper time and the proper sequence. Spark advance mechanism. Spark advance necessary and necessary to spark and occur with the combustion chamber with exactly the right instant for all engine speeds. And idle spark is usually timed to occur about 2 to 10 degrees before top dead center. A highly speed spark may occur with it at 40 degrees or more before the piston reaches top dead center. It's necessary to start the fuel air mixture before sooner at high speed because of the piston traveling much faster. In fact, the spark advance of the piston was well past top dead center, moving downward before burning fuel air mixture create enough pressure for the effective power stroke. There are two types of advance mechanism common will call for the distributor to deliver spark sooner than the cycle at the high speed. The mechanism are centrifugal advance and vacuum advance. Alright, this shows your breaker cam, advance cam, weights and weights weight springs, weight base and shaft assembly. Then it shows your no advance, weights, weight advance, cam, weight springs at low speed, full advance, high speed. Your centrifugal advance mechanism is used only in Army tactical wheel vehicles. This mechanism consists of the power weights mounted with the weight of the base fixed in the distributor drive shaft. The weights connected to the spring advance cams. These cams are fixed at the bottom of the breaker camshaft. Now let's see how the advance mechanism works. The engine runs at idle speed with the spring hold the weights in their retarded no advance position. The engine speeds up, the weights try to fly outward, but to do this they must overcome the spring tension, which they will do once the engine is running fast enough. As the engine speeds up, the weights gradually move out, not at only one time, but the smoothest grade even in advance. Let's suppose the engine sped up up its governed speed at the time of the wave of the move upward and the far as they cam, and the weights move, and the hook-free end of the weights rotate with the distributor cam in the direction of the cam rotation. Now, each of the distributor open cams will strike the rubbing block on the moving point with the sooner and cycle, causing the point to open sooner. This action causes the spark occur the distribution chamber earlier during the compression stroke and advanced times of the spark occurs. So this shows your vacuum timings, return, spring, vacuum passage, linkage, breaker plate assembly. Are your vacuum and advanced mechanism used with the non-used tactical vehicles commonly used in civilian type vehicle with the armored shaft car with the type of advance of the vacuum chamber that connect with the intake manifold and vacuum diaphragm, which is linked to the distributor plate. The diaphragm spring on the vacuum is outside of the vacuum when engine is not running. Air pressure from the both sides of the diaphragm is equal to the spring push of the breaker plate through the retarded position. When the engine is running in the manifold, vacuum is high. The atmospheric pressure pushes the diaphragm against the spring pressure spring movement of the diaphragm breaker plate with a full advanced position. If the engine is then pushed under load or for any other some other reason, manifold vacuum decreases, the spring is able to move diaphragm and retard the spark. A centrifugal vacuum mechanism, same as causes spark advance in different conditions. Centrifugal advance control the entire RPM. Vacuum advance responds to varying loads on the engine. When the load is great, there will be little or no vacuum advance, but the throttle valve will be open. The manifold vacuum will be low. Most high-speed engine civilian vehicles use both types of advance mechanisms on their distributors. When both are used, the spark advance will be respond to both engine speed and load. Alright, lesson 3. Learning event 3. Describe the operation principle of the construction of solid state general. The rise of the electrical ignition system due to the superiority of the electronic ignition over the conventional ignition system with the several major area of the system types of remove the one area of the maintenance of the ignition system that ignition contact points. Also, because of the ignition system produced with the higher voltage of the conventional system, the electronic ignition system usually can be fired fouled spark plug in an area with a high performance electronic ignition system are far superior with the voltage does not deteriorate as quickly as the high engine speed conventional ignition systems. But the ignition system does not contain ignition points where the ignition performance does deteriorate with mileage. Description: the electronic ignition system differs from the conventional ignition system that consists of a special pulse sending distributor electronic controls unit, 2-element ballast resistors, a second special ignition coil, ignition breaker points, capacitor. Using conventional ignition system has been replaced with a gear-like piece called the reluctor and pickup unit. The reluctor places the distributor used the conventional distributor, and the pickup unit is made up of a permanent magnet pole or piece of the coil. Or operation: the ignition primary circuit with the connect of the battery through the ignition circuit, which through the primary side of the ignition coil. The control unit with the ground of the secondary circuit is the same with the conventional ignition system. Magnetic pulse direct distributor is connected to the control unit. Alright, this shows your ignition switch, dual ballast resistor, electrical control unit, ignition coil, battery, distributor, and then it shows your electrical control unit, transistor, heat sink, plug connector, reluctor, tooth, and magnet pickup coil. Or the distributor shaft with the rotate with the distributor reluctor turns path of the pickup unit with each of the T with the 8-cylinder engine reluctor path with the pickup with the one with the during each of the distributor revolution. Make the reluctor teeth move with the pickup and the voltage is induced into the pickup unit. This is the tooth of the reluctor path of the pickup of the coil of the magnetic line forces the flow of the permanent magnet from the pole piece through the reluctor back to the magnet. Voltage is induced with the windings of these magnetic lines force pass through the pickup of coil of the voltage carry the pickup of the coil of the control unit with the distributor leave the pulse engine of the control unit. The signals control unit interpret the ignition primary circuit. They cause the primary circuit to collapse to begin with the induction of the magnetic lines of the force of the primary side of the coil and the secondary side of the coil. The induction provided the required voltage jump, the spark plug gap, ignite air fuel mixture in the combustion chamber. As the tooth of one reluctor moves away from the pickup of the primary circuit again, the complete of the magnetic field again is built up with the primary winding with the ignition coil where the weight of another signal from the pickup unit. The build-up collapse of the primary circuit that takes place very rapidly is brought about by the transistor action and speed reluctor. The advantage of the electronic ignition systems are transistors in control unit can make the break of the primary circuit much faster than the conventional ignition system. Higher primary voltage due to the cover of the system can be made with a handle higher voltage without harmful effects, whereas ignition point contacts quicker switch time of the switch system allows longer cool primary circuit build up and longer induction time when the primary circuit collapse. This increased time also allows the primary circuit to build up more current and secondary circuit to discharge more current. Higher secondary current produces a hotter spark at a spark plug, which allows the engine to operate more efficiently. Or your capacitive discharge ignition system. Show the battery ignition switch, the transistor, the cell phone rectifier, impulse generator, capacitor, distributor rotor, and a spark plug. This offers several advantages other than the system. Similar fuel volt transistor magnetic coil with a certain component that has been added to the primary circuit. There are more convertible capacitor thysistors, silicone controlled rectifiers. Power converter has an output range voltage of 200-300 volts. The voltage you charge the capacitor with the thyristor into the off condition. The thyristor rate is 1. Receive the signal with a pulse generated with the circuit of the anode and the cathode 2, 1, 2, and 3. Is slow. The capacitor immediately discharged with a high rate through the primary. The high secondary voltage can be reduced, reached at 100 times faster with the capacitive discharge system than with an inductive system. The grease and spark plug fouling material increasing potential spark plug life and other advantages that it uses less current either than conventional system than other solid state. This means less demand on the battery during standing starts and potential longer battery life. This page is left blank, and then it shows the practice exercises, your answers to the practice exercises, and moving on to lesson 4, accessory systems.